In this chapter, we are going to learn few core concepts around LLM. These are very important for us to understand. The core concepts here, what we are going to learn is like tokens, context window, prompt, and temperature. So before going into these vocabulary, let us trying to understand what we are trying to solve in this chapter. So you have seen that uh, in the previous chapter, the LLM, the large language model, is able to respond to all the questions. But the answers, the length of answers are different. So sometimes it gives us a lengthy answer, sometimes it gives us a different answer for the same question. So how do you control that behavior of the LLM is a very important thing we need to understand. Uh, the first thing which you have to understand is token. So let me jump into the whiteboard. That will help you to better understand this. Uh, yeah. So here we have a large language model. Our model is Llama model. We are giving input, like typically a question, and it is giving us an output. In our case, it's an answer. So essentially, the question is nothing but a set of tokens or words, okay, English words. Okay, so we are going to give a question in English. So, and it is going to respond the answer in tokens. So, if you want to understand, a token is not exactly equivalent to the word. So there is a some mathematical thing. What they say is one token is approximately 0.75 word. I'm going to dwell a little bit more into it. The simple way to understand is you give a input as tokens and you get output as a tokens. So that's a important thing we have to understand. Token plays a big role how LLMs are going to charge us. Let me share you one example from ChatGPT, how it is going to take treat the words. So pay attention to this. So if ChatGPT says welcome Smith, it costs two tokens, right? Every time you get output from whether you give input or whether you're getting output from the large language model, you are going to charge on number of tokens you are going to consume. So that's important. The more number of tokens you consume, your bill will be more. So one funny way to see is welcome Smith is causing two tokens. For example, if you change the same thing, if ChatGPT is saying welcome Balaji, my name, it is costing me three tokens. So, and why this difference? Um, I'm going to explain more when we are going about tokenizer and stuff. The whole thing, what you have to understand is, so based upon the data and the language on which it trained more, so the number of tokens also changes. I don't want to confuse you more on it, but I'm just giving you an example. So if I'm going to give you my mother tongue, uh, like you can see the same meaning. Okay, so it is saying a welcome in my mother tongue. Okay, and it costs six tokens. So other way to look at it is, okay, if ChatGPT is generating a different language, then it costs more. Another way to look at it is if it is generating an English book and it is generating a Telugu book, that's what's my language, or it is generating a Telugu content, the number of tokens are more, so you're going to pay more per token. So that's a one way to understand. When we are dealing with the tokenizer, I'm going to cover that topic. So now you understand tokens, right? It is nothing but you're going to give an input as a tokens and you're going to get output as a token. Then what is a context window? So input tokens plus output tokens, and maximum of this is nothing but a context window. So how much what is how much amount of text it can how much amount of tokens it can handle is a context window. So without compromising on the model performance. For example, the Llama model will take 128K tokens. So if we give an input of like 300K tokens, the model is going to drop some input and it is going to accept only 128K tokens and respond you within that context. So what I mean is if you give more number of tokens than its allowed limit, the performance of the model will drop down. So it try to respond in a non-contextual way. So that's the reason context window is very important. Now, typically the Claude models or the Claude models are GPT or Sonnet. These models have give us around 1 million tokens as a context window. Let us go to the slides back. Now you understand, right? So for example, roughly a 100 tokens text is nothing but 75 words. The other way to understand this, okay, is 128K tokens is sufficient for me. My language model generates 128. Yeah, it's more than sufficient. So if it can write a book also, a decent book around 300 pages, if you ask the language model to write a book with 300 pages, it can handle the context length around those many tokens. So now you understand the tokens, right? So typically, a, a simple formula to understand is right. Okay, one token is approximately 0.75 words or 75%. Now you know the context window, right? So context window is nothing but the input tokens plus output tokens plus the maximum that is allowed. So the other way is like the next thing which we are going to learn is prompt. Prompt is nothing but the input that you are going to give it to the large language model so that it responds back. This is what the context window is. The entire prompt and the system prompt. Stay there. I will explain what when you are dealing with what is a system prompt. Then user question and the model output and some room together. Okay, if you have some messages. So these all combined together becomes a context window. Uh, one thumb rule is if you try to give more information than a context window, if you try to give more tokens than a context window, then the performance of the model will be gone down. Third, temperature. This is one of the parameter that we need to understand. Now, I'll slightly walk you through the code, then you'll understand better about this uh, temperature. If you want a model to give a deterministic answer, which is like if I ask question or if you ask question, if someone other person asks question, it's going to give a deterministic. It's the same answer for everyone. Then the temperature should be 0. So when you are increasing the temperature parameter, okay, the randomness or uh, the incoherent ideas it's going to incoherent or not equivalent answers it's going to give. So when you want to have a deterministic, if the model has to give always the same answer, then put the temperature as 0. Okay. If it has to give good ideas or different answer on each run, okay, you can give zero point 0.7. Okay. So if it has to give an incoherent answer, you can go for a higher size. So the standard or the recommended for a few particular tasks. So if a model has to give an answer on your policy documents, what it is exactly determined in your policy document. Then you have to give the temperature around zero point 0.1 to zero point 0.9. This will help you to understand various values. The core concept is very simple. If the temperature is increasing, then the randomness comes more. So it will give you the random answers. If it has to be deterministic, reduce the temperature. That's a simple thought around this. Then the fourth important thing is like prompt. So what is prompt? Whatever input you are giving it to the model, it's nothing but a prompt, and it's going to understand your input, and it's going to give you the response back. There are two or three classifications here. First one is like system prompt. Then we call it the user prompt and assistant prompt, whatever the reply the model has given back. System prompt. With this example, I'm going to show you. This will help you to understand better the system prompt. You want to define the personality for the model, like the model should behave as an assistant for you, and it has to uh, give the answers which are fact. It has to didn't it shouldn't give a random answer. It has to obey your rules. You have to set a persona to it. So that's a system prompt. You can instruct in the system prompt, you can instruct the constraints that you can set to the model, how it should behave and everything in the system prompt. Then the user prompt is whatever the query you are giving it to it. This is called the user prompt. We go back. These are the like the system prompt are nothing but a constraint or persona. It needs to be a assistant or it needs to be a friend. You can set those personas in the system prompt. After that, you can ask the actual question. Then when the model replies, it has to store the message that we were going to see in chapter 6 to understand that. So these all the whole prompt, these all three types of prompts combined together, and the allowed limit is once again what you have seen about the context window. Now, very simple thing. The chat client, whatever the library which sits on top of a chat model, we have our code which is going to call the chat client library, which is going to call chat model, and in turn it is going to call Llama chat model implementation, and it's going to call the Llama language model. So this is the abstraction that Spring AI gives us. So if you want to move to from Llama model to uh, GPT models, the switch is happen here. You just have a GPT implementation and you have a GPT model. The rest of your code, no change. There is no change in your application code. So that's the abstraction that Spring AI gives us. Um, Yeah, the same thing what I have explained you in the code. Right. So in this series, we learned three or four concepts. One is token. Second thing is a context window and model response. Okay, how can you limit the number of tokens that the model sends back the user message? Okay, you can control. You can say 150 tokens or 200 tokens. You can limit the number of tokens that produces as an output. And you can tune the temperature as well, right? Okay, so if you want to have a precise answer, a creative answer based on the temperature, if the temperature is high, the model becomes more creative, like around 1.5 or something. If the temperature is around 0.1, it's going to be precise. This entire uh, s- uh, uh, this entire session uh, is you can access this entire session in the GitHub, so it's very easy to run. There is a curl commands that explains. Now, simple thing is right. I have a one REST API endpoint, and whenever we ask the question, it is going to give the precise answer. Okay, so I tune the parameters to provide the precise answer. So someone is asking what is a remote work policy. So the model is going to respond back. with the precise answer. Not sure. Yeah, I got the response. So this is how many times you ask the same question. The answer is a precise. So it's that's the temperature that we set. The endpoint for here is like if you see the precise, I want fully deterministic, and I have a kept cap on number of tokens that it produces, like 150 tokens, approximately 100 words. So this is how you can control the model response, whether it can be its randomness, or whether it can be the number of tokens it's going to send. The entire tutorial you can download and run them simply on your laptop. And there are some quizzes which you can go through and understand the concepts that we have learned. Uh, yeah. So, be- so if you like this session, please like, subscribe, and if you have any questions, drop a comment. This will help us to reach to the so many developers and improve the visibility of the video. And final note, this is not my merit. I have learned from Spring AI and Ollama projects. The entire credit goes to the community and the maintainers of this project. Hope you enjoyed this video. Thank you very much.